CNT125, Routers and Routing Protocol Lab. The last section we configured our router with RIP, and we actually looked at the RIP packets with our sniffer. So we are now going to take RIP off, and we're going to use something more current. We're going to use OSPF. So we're going to take RIP off the routers, and then we're going to configure with OSPF. So I'm going to go to my Harrisburg router, terminal connection, and I'm going to do enable. I'm going to do configure terminal or config T. That's my shortcut. You notice I'm using shortcuts already. And we're going to say no router RIP. And this is going to take the RIP routing protocol off. And along with it, if I do a show run, all the networks. That configuration would have been down here. It is now gone. Okay, it would have been in this area. It is now gone. So it's no longer running RIP. I'm going to go to this router. I'm going to do the same thing. Oops. Go to this terminal connection, enable, config T. We're going to do no router RIP. That just took the RIP routing protocol off. Again, if I do a show run, it would be down here, and it's no longer there. Okay, it would be in this area right there, and it's not there. All right, so on my Harrisburg router, let's add now OSPF. Okay, so on this router, let me slide this so we can see everything at once. Config T, configure terminal. We're going to say router. Now, I'm going to do a question mark. I'm going to show you something. If I do a question mark here, it says these are all the possibilities of routing protocols: BGP, EIGRP, OSPF, and RIP. It gives me 4 options on this router. So these would be the different routing protocols I could configure. So whenever I do a question mark, it lets me know options that I have there. Very handy. So I'm going to do router OSPF, and I need a process ID. If I have multiple instances of OSPF running, I can separate them with different process IDs. That's what this is. So router OSPF 2, and I need to plug my networks in. Let's do the first one. Network 192.168.10.0. And I would normally think of following this up with the subnet mask, 255.255.255.0. Well, on OSPF, I don't use the subnet mask. I use the inverse mask. Let me go to my notepad here real quick. Here is my network, 192.168.10.0, 255.255.255.0. When I do the inverse mask, any octet that would have been, 255 are all ones. The opposite is 0. And this is something we use when we do OSPF, and we also use inverse mask when we do access lists later on, basically after the midterm for you guys. So we need to use the inverse mask. And what this tells the router is, hey, these octets are like network, and this right here is host. Don't worry about it. So this is a way to tell the router what parts are network and what parts are host. So when I do inverse, I basically, if it's 255, I put a 0 there. Okay, that's the simple way to do this. Now, later on, it'll get a little more complex, and I will show you more to be able to help you with that. But for now, wherever I have a 255, I'm going to put a 0, and wherever I had a 0, I'm going to put a 255. That's what I'm going to do. So here, 0, 0, 0, 255, and I now need to also specify area 0. Again, I could have OSPF running. Think about hack. I could have OSP running at Harrisburg, Lancaster, York, Gettysburg. I could have it running at different campuses. And when I do that, I might specify a different area number for each campus. What we're going to do area 0 as if all of this belongs to the default area. That's what area 0 is. It's kind of the backbone or the default area. So we're going to put all these networks in area 0. We're then going to say network 10.0.0.0 followed by 0, 255, 255, 255. And then we're going to do network 172.16.0.0, 0, 0, 255, 255, area 0. That's all 3 networks. And if I do a show run, there is my OSPF config. It's now running on my router. So what I would do is I would do a copy, run, start, save my config, okay? And I will come out here and I will also do a save on my packet tracer. And I'm going to go repeat this on the Philadelphia router. So config T, configure terminal, router OSPF, PF2, network 192.168.10.0, 0.0.0.255 area 0, network 10.0.0.0, 0.255.255.255 area 0, network 172.16.0.0, 0.0.255.255 area 0. Now, a message popped up there that it's loading stuff in its OSPF table. I'm going to repeat that last command just so you can see there's the whole command, 172.16.0.0. Okay? I'm going to do an exit. I'm going to do a show run. And there is all of my networks for OSPF. So again, I will do a copy, run, start on this guy. And OSPF should be up and running on my router. So, that's all this right here. We saved our config. I would do any troubleshooting if links are not functioning. Okay, I would do some troubleshooting. I want to do a trace route through to make sure with OSPF it's now working, so I will do that. I'll go to my command prompt here, and I'm going to hit the up arrow because I did this before, and I'm going to trace route through my network. Hopefully everything is functioning. If not, I might need to give it a minute. And actually it timed out on the first attempt, but it did it on the other ones. So we have a full trace through the network. So my network, when I took RIP off and put OSPF on, is now functioning like it should. So my network's up and running. Now, if that did not work, I would go back and use these troubleshooting tips right here. Work through that. I got my successful trace through. So now I want to look at my routing table and my OSPF packets, if you will. So let's go look at the routing table on the Harrisburg side. Terminal. Let's do a show IP route. And what I should be seeing is a similar table. And it is. But I see that this route is learned through OSPF now. Everything else is pretty much the same. I get to the 172.16 network via this interface, going to this IP. It's basically, now this is a composite metric. This uses bandwidth as well as distance, so it shows a 2. And then it also shows the administrative distance of 110, because OSPF is a little bit better than RIP, so the quality of the information is better, so that number is lower. Okay, so there is my OSPF table on this router. I'm going to copy that. Right-click, copy. I'm going to open my notepad. I'm going to make a new file here. Actually, I'll just delete this. 125. I'm going to call this OSPF routing table just so I know what I got here. I will paste this in. And I'm going to go look at the other router. Actually, let me call this guy OSPF routing table. I'm going to save that because I need to save that for submission. Make sure you have the TXT in there. And I'm going to go look at the other router real quick. You'll see, just like before, it's almost identical. So, there we go. Show IP route. And I'll make this wider so it's easier to see. Again, there is my OSPF table, the 10 network, the 172 network, and then lastly, the 192 network. In this case, the 192 network is learned through OSPF. I go to this interface, leave this interface, go to this IP. It's basically composite metric 2 away, router and bandwidth, and then actually bandwidth and distance, excuse me. And then there's your 110, your administrative distance for OSPF. I don't need to, but I will save this config or save this routing table as well, so I have both. I just need to really see one, but I'll put that one in there as well. I'll save that file. I'll close my connection there. And I now want to look at the OSPF packets in my sniffer. So I'm going to open my sniffer. I'm going to edit filters. Actually, I'll do show none. Edit filters, and this time I want to see OSPF. And I will clear the packets that are there. Again, I'll wait just a minute, and I'm going to look for an OSPF packet. And again, just like with RIP, I want to look at the source and destination IP. We're going to see something slightly different this time. So this time, I see OSPF. I'm going to look at the source IP, 192.168.10.1. That's the router. That makes perfect sense. The router generated this OSPF message. The destination this time is no longer a broadcast. 224 is 005. 224 is a Class D multicast. So this is sending out a message to just the routers that are part of the multicast group for routing updates. So OSPF is going to multicast its tables to the other routers in the network that belong to the OSPF processing or programming, if you will. If I look at the Ethernet header as well, I'm going to see the destination MAC is 01005E. That is a multicast MAC prefix, if you will. So anytime you see a 01005E, or anytime a router sees 01005E, it knows it's a multicast. And if I look closely at the end of it here as well, 0005, that matches up with this right here. So by MAC address, it knows it's a multicast, and it knows it belongs to this multicast group set by this IP, which is pretty awesome. It's pretty cool. So there is my OSPF updates, multicasting out instead of broadcasting. Make sure you make note of these, because these are part of review questions as well. All right, in the last part, we will gather up all of our stuff for submission to D2L.